Let's discuss a question on the machine design. Well, you have a shaft given like this where the bending moments are acting this way, and we are asked to find out nominal stress. So obviously the least cross section is something which will have the max stress. Okay, so if we focus our attention, because the bending moment is same, only the cross sectional difference in the cross section minimum here, so that will produce maximum stress. So we will just find out for this cross section. So we'll use the bending equation. M by I is sigma by y. Okay, and I for a circular cross section is pi by 64 d power 4, pi d power 4 by 64. That is your I for a circular cross section, small d. Okay, and y is d by 2. So going by this, if I use all together, I'll get 32 m by pi d cube. If I use all these things in this, the stress will be 32 m by pi d cube. But we want in capital D, and D is given as 2d. So D is d by 2, and that if you substitute it here, so you will be getting 32 m by pi d power 2 whole cube. So that is whole cube, so that is 8 into 32 m, 2 power cube is 8, so pi d cube, and 32 into 8 is that 256. So 256 m by pi capital D cube. So this is the stress, the max stress that sets up in the right side corner. Okay, so A is the answer. Okay, so this is a simple problem. Only thing is you have to understand which one is. So if you, just curious, if you calculate the stress here, let's say the stress here, then it will be 32 m by pi capital D cube, right? So yes, going by this logic, so in that sense, if you compare the stress here in the part, the lowest cross section part and the bigger cross section, so in one we are getting 256 m by pi d cube, in the second it will be 32 m by pi d cube. So obviously one is more, and that's why at the start also you can fix it, or even you can calculate stress in part 1, part 2, and then whichever is the maximum is the one you have to report. So 256 m by pi d cube is the answer. Thank you.